Yes, now we get to some of the fun stuff. Ellipses. Woo woo! And let's talk about ellipses for just a moment. This is an ellipse. We sometimes call these ovals, but the correct term in mathematics is ellipse. And if we look at the equation that makes an ellipse, we'll notice that what makes it different from a circle is these two numbers right here are different. On a circle, they have to be the same. This is like 1/49th times x minus 2 squared plus 1/9 times y minus 1 squared equals 1. Yes, it does need to be set equal to 1. Forget about that for just a moment. If it were a circle, it would have been 1/49th and 1/49th, or 1/9 and 1/9. Just looking at the equation, when it's given in this form, there's a couple things that we know just by looking. First, we can get the center of the ellipse from the equation. It's the opposite of that is our x value, and the opposite of that is the y value. So the center of this ellipse is going to be the point 2, 1. If these were plus signs, then they would be negative values for x and y. Another thing that we need to be aware of is whichever denominator has the greater number. Here 49 is obviously greater than 9. Whichever denominator has the greater number, that's going to be your major axis. So this will be our major axis here. It's under the x's, so it will be longer going left and right than it will be going up and down. This value is a squared. This value is b squared. Now, if the roles were reversed and the greater number were under the y's, then we would have a vertical ellipse. And since the greater number would be under the y's, it would be A, and the other one would be B. A is always going to be the greater denominator. Well, like I said, this is A squared, and the square root of 49 is 7, so A equals 7. And the square root of 9 is 3, so B equals 3. This gives us the length of the vertex or co-vertex from the center point. And we'll get into that in just a minute. The major axis, the one going in the x direction, left and right, will be twice that much. So the major axis is 14 units long, 2 times 7. The minor axis, in this case it's on the y-axis, or in the y direction, up and down, it's 2 times that, so it's 6 units. We're going to use these numbers again in just a moment when we calculate the foci. Alright, so right from the start, here's what we can do. We can plot the center point. It's going to be the point 2, 1. Now I don't have this on a coordinate system. I'm just going to mark this point, and I'm going to call it the point 2, 1. Now this is what I would be doing if I had to graph an ellipse. Go plot the center point. Now, I need to mark this vertex. The vertex is going to be this number of units away from the center point. Since it's a horizontal ellipse, I'm going left and right. So I'm going to go to the right, 7. If I go just to the right, it only affects the x value. So this point right here will be my center point, the x plus 7, and the y value stays the same, so it's the point 9, 1. Now I need the vertex on the other side. This time I'm going to the left, so I'm going to subtract 7 to give me the x value that goes here. So this point will be my center point. Since I'm going in the x direction to the left, I subtract the length of A. And the y value stays the same. So it is the point -5, 1. I have those two vertices plotted, so now I can draw that axis. If I did that correctly, then this should be 14 units long. The major axis is 2 times A. All right, so going from -5 to +9, it'll take you 5 to get to 0, 9 more to get to 9, 5 plus 9, 14. Yeah. Now my minor axis is 6 units. B equals 3. So from the center point, I need to go directly up B number of units, 3. If you're going up, that affects the y. It's going to be right about there. This point will be, okay, I'm not going left or right, I went straight up, so the x value doesn't change. The y value, 1 plus 3. So this is the point 2, 4. That covertice is at 2, 4. And already I got off here. That should be about, not far off. Should be about right there. And here's my other covertice. At the ends of the major axis are the vertices. At the end of the minor axis are the covertices. I can connect those. And then we'll talk about how to get the coordinates for this other covertice. From the center point, I go down 3 units. Going down only affects the y, it doesn't affect the x. So this point is going to be 2, 1 minus 3. That means it's the point 2, -2. Now my minor axis should be 6 units long. So let's see, going from -2 to +4. So I go up from -2 to 0, that's 2. And then I go 4 more, is 6 altogether. So I believe I have the vertices plotted correctly. The last thing that we're going to do is we're going to plot the foci. Foci is a little point that goes right here and right here. It actually is the same from the center point. Sorry. It goes out from the center point, and then it makes a right triangle with the covertice. The length of this line segment going from the foci to this covertice is the same length as this is right here. It's 7. Now, they also call the length of this line segment A in the book. This is B, and this is called C. C is from the center point to the foci. This line segment here is the same length as from the center point to this vertex. I know that's a bit confusing. Just reconcile that in your head. Look at what we have here. We have a right triangle. Here's the hypotenuse. This time the hypotenuse is not called C. It's called A because it's the same length as this line segment here. Here's B, here's C. This is what you need to find the length of. It's not the longest side of the triangle this time. So to get it, it's going to equal the square root of the longer side of the triangle minus the other short-sided triangle. And here's A and B. So this is going to equal the square root of 7 squared minus 3 squared. And we already know what those were squared. So it's the square root of 49 minus 9, square root of 40. So you get your handy dandy TI-84 Plus calculator, and you do, not y equals, you do square root 40, enter, 6.3. Okay, so we need to come this way 6.3 units. So for the foci, it's going to be the center point, 2, 1, going in the x direction, so 2 plus 6.3, comma, 1, and that gives you the point 8.31. And then do the same thing for the other foci. It's going to be right about there. It is going to be the center point, 2 minus 6.3, comma 1. So that's going to give us the point negative 4.3, comma 1. That's that point right there. Now, if you're only graphing the ellipse, then all you have to do is get the two vertices. Well, you have to get the center point. Then you're going to use that to get the two vertices, the two co-vertices, then connect them with a smooth curve. The majority of your questions, though, are going to be what is the length of, or what are the points that make the vertices, the co-vertices, what are the points for the foci, what's the length of the major axis, what's the length of the minor axis of each. And those are all going to revolve around what we just did right there. It's not the most difficult process in the world. You can do it. You can do it. Read these notes. I explain how to find each of those. What you need to be aware of is that when you have an equation in this form, this is a squared. To get a, I know I said that it will be under the x. This is the square root of that number. That was 49. That makes a 9. That was 9. So b equals 3. H and k, the opposite of h, the opposite of k means here's h, here's k. Take the opposite of negative 2, it's positive 2. Take the opposite of negative 1, positive 1. That's what I mean about opposite h, opposite k. All right. What funness. Okay, sometimes you'll be given an ellipse and it won't be in standard form, like this one right here. Okay. Well, you have to get it in standard form. So move the x terms and the y terms all to the same side. And your goal in that part is to make the x squared and the y squared positive. Positive. So we have negative 16y plus 52 equals negative 2x squared minus 8x minus y squared. Whole bunch of ugliness. So we'll just call it, well, I won't mention any names. You know who you are. Okay, here we go. X squared is negative. It needs to go over to the other side. y squared is negative. It needs to go over to the other side. We could just multiply the whole equation by -1. Let's just move things. So plus 2x squared, move that 8x while you're at it, plus y squared. Same thing over here, plus 2x squared plus 8x plus y squared. Let's care that, and that, and that. So over here on the left-hand side now, we have 2x squared plus 8x plus y squared minus 16y plus 52 equals 0. Ew. Alright, this 52 needs to go over here. So now 2x squared plus 8x plus y squared minus 16y equals -52. Alright. Well, so I still don't have anything in the form of a ellipse. And that's because, yes, da 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 da. At this point, we need to start completing squares. That's right. That's what I said. Complete the square. For a moment, I'm going to separate the x's and the y's. Alright, and here's what I see. I see right here with the x terms that I can factor a 2 out of that. So I'm going to do that. 2 times x squared plus 4x plus y squared minus 16y equals -52. All right. Let the squaring begin. To complete the square, you take half of this number and you square it. Half of 4 is 2, and 2 squared is 4. All right, we've done this enough. This shouldn't be foreign to anyone. You should be able to do this. So far, there's not a new part, not a new part. Here's the new part. Half of this number is 2, and square it. It's 4. Now we're going to do the same thing here. Half of this number is 8. And now square it. 8 squared is 64. All right, on this side we have minus 52. Now, what we have done is we've created an unbalanced equation. We've added parts to this side, but not to this side. So we need to balance it. Here, we've added 4. But that's not entirely true because it's 2 times all of this. So in actuality, what we have added to this side is 8 when we completed the square for the x's. And to this part, for this part on this side, we've added 64. So we need to add 64 to this side. And now we can go ahead and condense this into its binomials, since now these are perfect squares. And what we have here is 2 times x plus 2 being squared, plus y, because that's a minus there, this needs to be a minus here, minus 8 being squared equals. Okay. Negative 52 plus 8 plus 64 is 20. We're almost there. We did all that moving to the other side to get that 20 right there, and it turns out we can't have a 20 there. What to do? What to do? What we need there is a 1. So how are we going to turn that into a 1? Well, I can divide this by 20. 20 divided by 20 equals 1. But if I divide this side by 20, I've got to divide this side by 20. So we are going to do that as well. Divided by 20, divided by 20. Now, if this 2 weren't right here, this would make a circle with a radius of 1. But because the 2 is there, it's going to create an ellipse because the 2 and the 20 reduce. 2 goes into 2 one time, so 1x plus 2 squared. 2 goes into 20 10 times. Plus y minus 8 being squared over 20. This one doesn't reduce. Yaha! Yaha! Now look at what we have. Now we have the equation for an ellipse. This is going to be a vertical ellipse because the value under y is the bigger denominator. Okay. This is a squared now. Remember, a, or a squared, is going to be the denominator with the greater value. Here's a squared, here's b squared. The center of this ellipse is going to be at the point -2, +8, opposites, h and k. Okay, so we have the center at -2, -8. The major axis is going to be in the y direction, up and down, because the largest number is under the y's. And the square root of 20 is about 4.5. Okay. So for the endpoints of my major axis, it's going to be -2, 8 plus 4.5, and -2, 8 minus 4.5. So -2 and 12.5. And -2, 3.5. Those will be the endpoints for my major axis. For my minor axis, I start at the center point again, the square root of 10. About 3.2. Okay, my minor axis is in the x direction, so it's only the x value that changes. So I have -2 plus 3.2, 8, and -2 minus 3.2, 8. So the co-vertices will be the 2 points, -2. I just messed that up, didn't I? It's -2 plus 3.2. So 1.28 and -5.28. I think you can do the rest. If you have to find the foci now, it's square root a squared, here's a squared, minus b squared, here's b squared. That gives you the length, and you add and subtract it from the center point. You have your two vertices, your two co-vertices, and you have the center point so you can draw the ellipse if you need to. The biggest struggle was just simply working this equation down to this form right here. That's what's going to take you a little bit of time, but I've given you plenty of time to do it. Now there's a couple of other things that on the worksheet called the eccentricity of the ellipse, and that's just a ratio that describes the roundness of the ellipse and also the length of the lattice rectum, which is a line segment that is perpendicular to the major axis, and it goes through the foci. That is the lattice rectum. And if I'm not mistaken, the formula for that is a squared divided by b. But anyway, I didn't ask you to find them. They're not in the book. They're not covered in the Algebra 2 book, but they were on this worksheet. But you have everything that you need to be able to complete that worksheet. And also, I think I gave you an assignment in the book. Can you graph these in the calculator? And the answer is yes, you can. But in order to graph them, you have to solve for y. I did one. And this is what I got. You have to do the positive of that and also the negative of that in order to get both parts of the ellipse. And here's what it will look like when you graph it. Pretty neat, huh? Do well for me and don't give up. If you have questions, call me, message me, send me an email. You can make an appointment to come up here to see me. I'll make my time available to you. So you just let me know when you can be here and we can meet here and we can go over this. Thanks. Bye.